So silviculture is all about manipulating forest ecosystems. Before we get into how to do that and why you would want to do that, it's worth exploring in real general terms what we have the ability of manipulating as foresters. Species composition is the first stand characteristic that we can alter through management. The slide illustrates a mixed oak stand at DuPont State Forest on the left and a white pine plantation at DuPont State Forest on the right. Before we get into specifics on how we alter species composition, it's important to recognize that it's a relatively simple process to reduce species diversity. You can move from a diverse mixed hardwood stand to a white pine plantation in one rotation, in one management action. We'll talk about the term rotation in a little bit, but it's significantly more difficult to change a white pine plantation back into something more diverse, back into a diverse hardwood stand. Typically, something like that can't be done in one rotation. So, something to think about. This slide here illustrates in a general way how our chosen silviculture may influence species composition. Both of these pictures are from forestry operations in Oregon. On the left, the silviculture employed, as you can tell, utilizes relatively large clear cuts, large-scale clear cuts, whereas the silviculture on the right employs the use of what could be considered a group selection technique. Now, the ecological impact of both harvesting regimes varies, but the point I want to get across here is really just in terms of what these two systems mean in terms of the establishment of different species. The picture on the left, the management system on the left, provides for the establishment of shade-intolerant, fast-growing pioneer species, and harvesting like that is typically tailored to planting these particular species, artificial regeneration. While the one on the right, the harvesting system on the right, lends itself to the establishment of shade-tolerant or intermediate species that were likely present in the understory prior to harvest. The point is, we control species composition by altering the nature of our introduced disturbance. The main thing that we have control over is the amount of sunlight that can hit the forest floor at a given time. In addition to species composition, we may alter stand structure as well, or how the trees are arranged within the stand. The term horizontal structure refers to the spatial patchiness of a stand. Think about walking through a forest where all the trees are similar in age, and there are no significant gaps in the canopy or patches of younger forest as you're walking through. A forest like that has little horizontal structure. Now think about walking through a different forest of the same size, but as you walk through, you're moving through patches of newly regenerated forest with many small trees per acre, patches of mid-aged forest with fewer but larger trees per acre, and patches of really old forest with even fewer but even larger trees per acre. This condition is indicative of a forest with a high amount of horizontal structure. The term vertical structure refers to the number of layers of vegetation within the stand. It's the difference between a forest with one canopy layer and little or no understory vegetation, and a forest with multiple crown classes within the canopy and a well-developed understory and midstory, and layers of ground vegetation as well. Typically, increases in structure, both vertical and horizontal, results in an increase in habitat diversity. Another primary stand characteristic that we can alter through silviculture is stand density. The term stocking is a subjective classification of a given density. And when I say density, it's the easiest way to think about it is number of trees per acre. When we say a stand is overstocked, we're stating that the number of trees present is too great and there are not enough site resources to go around. A certain percentage of the trees present will soon die naturally, and this is a natural occurrence as stands progress through succession. The more vigorous, the genetically superior trees get larger, utilize more site resources, the trees that are outcompeted eventually die. We manipulate density to maintain and increase the vigor of trees that we aim to keep in the stand. In essence, we choose, instead of allowing nature to choose, which trees are removed as a result of competition. When we implement silviculture, we are introducing disturbance in addition to the expected natural disturbance that will occur. The term prescription is typically utilized to describe a chosen silvicultural technique. Based on the ecological setting, we prescribe a treatment to be implemented in order to meet the objectives of the landowner. At the most basic level, silviculture can be implemented to accomplish one of two things. Silviculture may be directed towards the initiation of a new stand of trees. These are referred to as regeneration treatments. Or silviculture may be initiated to tend to the existing stand. These are generally referred to as intermediate treatments or thinning treatments. In forestry, what matters is the ecological result of the management technique, not what the management technique is called. It is very common for individuals to use the language of silviculture to describe actions that are not purposeful management actions. So above all else, I want everyone in this class to have the ability to use functional definitions regarding silviculture treatments. I've heard variations of the comments included on the slide my entire career, often particularly in the southern Appalachians where the majority of our stands are even-aged. The smaller trees are the losers in this competitive struggle, and so harvesting only the larger trees will do little but impoverish the residual stand. Just because you're cutting a tree here and a tree there, that doesn't mean you're conducting a true selection harvest, which is a legitimate silvicultural treatment. It has a particular place. The concept of tree maturity can be looked at from several different perspectives. You need to know how to set those thresholds depending on the goals of management. Your task as forest managers will be to recognize the need for active management, if there is a need for active management, and apply the appropriate technique and utilize the proper language to describe those techniques. So as I mentioned, silvicultural treatments can be implemented to either tend to an existing stand or regenerate a new stand. In addition, there are a whole group of even-aged silvicultural techniques designed to manage even-aged stands, and uneven-aged silvicultural techniques designed to manage uneven-aged stands. An even-aged stand is one where the trees vary little in age, typically no greater than 20% difference. That doesn't mean every tree is exactly the same age. It just means that the trees have become established following a single disturbance, whether that's natural or human-induced. Many of our forests in the southern Appalachians are even-aged because they've become established in one of two ways. They've either become established following a clear cut of the forest prior, or they've become established following the abandonment of agricultural land. In these scenarios, where trees are generally the same age, the most vigorous trees are the largest, and there is little correlation between age and size. You have small trees that are the same age as the bigger trees. They're just the weaker of the group. The smaller canopy trees will not respond well if the big trees are removed. This is a really important concept that we'll get back to. When implementing silviculture in an even-age stand, you apply it to the whole stand. If you are thinning, you generally thin the whole stand. If you are regenerating, you apply your chosen regeneration technique across the entire stand. Even-age stands are managed on a chosen rotation length. The rotation length is the age at which trees in the stand are deemed mature. The most common measure of maturity is growth rate. So trees are essentially growing until they die. They're growing until they're not anymore. But all trees reach a point where their average annual growth rate peaks. That's to say they're never going to grow as well as they are at that point ever again. That age, the age of the tree at that point where growth rate peaks, is referred to as the physical rotation length, or the biological rotation length. And this age varies species to species, and therefore different species are managed on different rotations. Uneven age stands are the result of several small disturbances, either natural or human-induced, resulting in 3 or more distinct age classes across the stand. A typical uneven age stand will contain many younger trees, fewer middle-aged trees, and even fewer older trees. In uneven age stands, size is more closely correlated to age, with larger trees generally being older than smaller trees, which are generally younger. Management of uneven age stands is a pretty complicated thing. It really requires the knowledge of the growth requirements of the species being managed for, and how they may respond to different levels of disturbance. You can think of an uneven age stand as a series of very small even-aged units. Uneven age stands are managed on cutting cycles rather than rotation ages or rotation lengths. So cutting cycles may range from 5 to 20 years, and on that cycle, whether it's every 5 years, every 10 years, every 20 years, when you enter the stand, you are thinning and regenerating in different portions of the stand simultaneously. You're thinning the younger age classes, and you're regenerating the older age classes that have reached maturity. The maturity of the oldest age class is often based on the same growth considerations described for even age rotation lengths. So again, the first decision we need to make is whether we are first, we need to make the decision of whether we need to do anything at all or not. If we decide there is something that we need to be doing, it is either going to be an intermediate treatment, a thinning, or a regeneration treatment. For the purposes of the next few slides, it's easiest to think about these treatments as they apply to even age management. All of these thinning treatments that we're going to talk about, you would apply uniformly to an even age stand. So the techniques of thinning in all its variations involves the removal of some trees in the stand to benefit others. Thinning harvests are initiated to improve the quality and value of the stand, improve the vigor of the residual trees, influence species composition, shorten the time it takes for the residual trees to reach a merchantable size. Thinning harvests can provide periodic income. It's for the landowner. There's a lot of reasons why you'd thin, but fundamentally what you're doing is increasing the vigor of the trees you're leaving behind. Regeneration harvests are conducted once the stand is deemed mature. And what it amounts to is the strategic removal of trees to provide the growing conditions required for the next desired cohort of trees, the next desired generation of trees. Even age stands, again, are regenerated based on rotation age. Portions of uneven age stands are continuously regenerated based on the specified cutting cycle. Regeneration harvest can result in significant structural changes to the forest and also significant species composition changes. It's really important to make regeneration decisions with clear intentions regarding the desired future condition of the forest, both structurally and in terms of species composition. And so now what we're going to get into are some specific silvicultural treatments that are commonly applied. We're going to begin here first with pre-commercial thinning practices. The term pre-commercial refers to an out-of-pocket expense, a thinning treatment that will cost the landowner money. They're viewed as an investment in the future value of the stand or the future health of the stand. The term uniform pre-commercial thinning is most common, or the technique of uniform pre-commercial thinning is most commonly used in dense, newly regenerated, pure stands of pine. Typically these are yellow pine stands, southern yellow pine stands like loblolly pine or shortleaf pine that were planted following clear-cut harvests of the original stand. This type of thinning is typically accomplished by hand crews with brush saws or chainsaws. The treatment is referred to as uniform because the primary goal is to increase spacing and reduce density. There's little attention is paid to which trees are chosen to leave because, generally speaking, they're all about the same. This type of thinning by maintaining stand vigor, decreases the susceptibility of residual trees to insect infestation and disease. It also may shorten the rotation length. It's going to shorten the the amount of time it takes the trees left behind to grow to the desired size, the desired product size. It's going to shorten the amount of time it takes for the tree to grow into a saw timber size tree.